Hello, and welcome to our educational video series. Today, we are going to cover how to prepare and load a powder catalyst sample in the in-situ capillary cell with a 1 mm capillary. Prior to preparing and loading the sample, you should set up your bench space and collect all necessary tools, chemicals, and consumables needed for sample preparation. To prepare your bench space, cover the area in bench paper that has been clearly labeled with your name, dates you will be at SSRL, and the beamline you are using. Prepare 2 hazardous waste bags, one for epoxy waste, and one for your chemical aka sample waste. To prepare your sample you will need the following tools: a ruler, a thick pointed Sharpie, tweezers, thin gauge stainless steel wire, 1 to 2 U-brackets, and 2 7/16 inch open-ended wrenches. You will also need the following consumables and chemicals: 1 mm capillaries, whey paper, small whey boats, Q-tips, 5-minute epoxy, and quartz wool. Lastly, you'll need your sample that has been sieved using an 80 to 120 mesh size and has been diluted if needed according to the CAT mass calculation. Carefully remove a capillary from its container. Tweezers may be used if the capillary is hard to reach with your fingers. The ideal bed length of the capillary cell is 1 cm based upon the size of the uniform heating zone between the heaters. Marking the position of the desired catalyst bed on the capillary facilitates preparation. Align the end of the capillary to the 0 mm position on the ruler. Use the Sharpie to mark the capillary at 45 and 55 mm from the end. The space in between the two marks is where the catalyst bed should be positioned. With one hand holding the capillary about 1 cm from the end, and another hand holding a vial of quartz wool, poke the end of the capillary into the quartz wool. You should be able to feel the capillary tube piercing the wool. Once you have about 1 to 2 mm of quartz wool inside the capillary, use the stainless steel wire to move the quartz wool so that it aligns with one of the Sharpie marks. This section will be designated as where the thermocouple will sit. Use a second wire to press the quartz wool from both ends, forming a secure plug. It is important to know how much sample is loaded in the capillary, as signal strength and data quality are dependent on sample mass. Take the capillary with quartz wool to the balance and either tare or weigh it to get an initial mass using the sawhorse. Loading the catalyst into the capillary is a repetitive process involving adding sample and ensuring the sample packs evenly in the capillary. Pour some of the sample onto the whey paper. With one hand holding the weight paper, and the other holding the capillary, scoop some of the particles into the capillary, tapping the bottom of the capillary on the bench to move particles farther into the tube. Once you have some sample inside the capillary, rotate it vertically, and slide the capillary along the ridges of the tweezers. The vibrations along the capillary will get the particles to flow down the capillary and pack more evenly. You now repeat this process until you have filled the 1 cm bed length. With the sample bed packed, you now go back to the balance to reweigh the capillary. 24 mg. Neat. To stabilize the catalyst bed in the capillary, a second piece of quartz wool is added to the top. With one hand holding the capillary vertically, and another hand holding a vial of quartz wool upside down, poke the inlet side of the capillary into the quartz wool. You should be able to feel the capillary tube piercing the wool. Once you have about 3 to 4 mm of quartz wool inside the capillary, use the stainless steel wire to move the quartz wool to the other Sharpie mark. Be careful to not pack the powder, just enough to compress and hold it in place, avoiding any pinholes. This section will be the inlet side of the capillary. Take one of the U-brackets and inspect for a Sharpie mark indicating which side the thermocouple will enter from, and a second mark noting where the thermocouple ends on the bracket. Align the capillary and U-bracket such that the two thermocouple ends are on the same side. Slide the capillary through the end of the bracket until the end of the quartz wool is approximately at the mark indicating the end of the thermocouple. Now it's time to prepare the epoxy to make the seal. Squeeze about 1 raindrop of each part of the epoxy into the small weigh boat. Recap the epoxy so it does not leak or dry out. With the Q-tip stick, vigorously mix the 2 drops together for about 1 to 2 minutes. Let's bring the capillary back into the scene. We are now going to apply epoxy to areas where the capillary meets the U-bracket. Take a dab of the epoxy mix with the Q-tip and hold it with one hand. With the other hand, slide the capillary to the right about 5 mm and hold it in place. While rotating the capillary, apply the epoxy mix. Slide the capillary back about 5 mm into the U-bracket. Repeat with the other side to get a seal with epoxy in between the capillary wall and the U-bracket tubing. Take a dab of the epoxy mix with the Q-tip and hold it with one hand. While rotating the capillary, apply the epoxy mix. Go back and make sure that the quartz wool aligns with the Sharpie mark on the bracket where the thermocouple tip is. Wipe the excess epoxy off the Q-tip with a Kim wipe. Wait approximately 5 to 10 minutes for the epoxy to cure on the U-bracket. Dispose of the weight boat in the epoxy waste bag. It is a one-time use.
5 minutes later.
Now that the epoxy has cured, you need to install the U-bracket onto the outlet block of the capillary cell. With one hand holding the bracket and the other holding the outlet block with the thermocouple, thread the thermocouple through the capillary. Any bend in the thermocouple will make this step challenging. Be careful to not get the thermocouple stuck, as you can shatter the capillary in the bracket or pierce a hole in the cured epoxy. Once the thermocouple has made it to the quartz wool, finger tighten the compression fitting joining the U-bracket to the outlet block while rotating the bracket so it's at a 45 degree to the block. Feed the outlet block through the guide rails of the capillary holder. You see that now sometimes the capillary bracket does not align with the inlet compression fitting. While holding the bracket, loosen the compression fitting on the outlet side, and that allows you to connect and finger tighten the inlet compression fitting. When looking at the capillary down beam, the bracket has to be 45 degrees relative to the table to allow the transmission of photons and enough space for the top heater coils to be placed later on. Once you ensure this position, use 2 7/16 wrenches to seal the compression fittings on the inlet and outlet blocks. Secure the outlet block by tightening the 2 screws using a 3/32 Allen key. Position the cell facing you so that the outlet block is on the right. Now that we have our heaters, install the terminal block on the outlet block by tightening the screw using a 3/32 Allen key. Take one of the heaters and orient it so that the set screws are facing you and the metal bar is pointing towards the outlet block. Slide this heater into the top hole of the outlet block. Install the bottom heater in the same manner. Prior to securing the heaters in place, the heaters need to be positioned properly. First, rotate the heater coils so they are directly above and below the capillary. Next, Slide the heaters in or out of the outlet block so that the thermocouple is covered by 4 coils of each heater. Tighten the screws on the outlet block to hold the heaters in place. Finally, use the set screws holding the ceramic rods to adjust heaters closer or farther away from the capillary. The ideal gap between the capillary and the heater wires is about the thickness of a credit card. Congratulations on assembling the capillary cell with a 1 mm capillary. Thank you for watching this video. If you have any questions, please reach out to us. Co-Access, part of the Suncat Center for Interface Science and Catalysis, is supported by the U.S. Department of Energy, Office of Basic Energy Sciences, Chemical Sciences, Geosciences, and Biosciences Division.